What is blockchain technology? Understanding cryptocurrencies' blockchain technology is essential for anyone exploring digital finance. This concept powers Bitcoin, Ethereum, and thousands of modern crypto projects. Whether you are a beginner or an experienced professional, learning how blockchain works helps you understand why cryptocurrencies are secure, transparent, and revolutionary. In this guide, we will break the technology down step by step. You will see how it works, why it matters, and how it continues to transform industries far beyond digital money. How blockchain works. Blockchain is a digital ledger. It records data in blocks. Each block connects to the previous one. These blocks form a chain. Because the data is stored across many computers, the system is extremely secure. Blockchain eliminates a central authority. This means no single person or institution controls the network. Instead, thousands of computers validate every transaction. This decentralization makes cryptocurrencies' blockchain technology resistant to manipulation and hacking. The system relies on mathematical algorithms, cryptography, and consensus rules that ensure all participants agree on the state of the ledger. A key feature is immutability. Once data is added, it cannot be changed. This creates trust without needing middlemen. Traditional banks use centralized databases that can be modified. Blockchain technology protects data from tampering. Nodes play a crucial role. A node is any computer participating in the network. Nodes store a full copy of the blockchain. They independently verify transactions. This guarantees accuracy and transparency. Consensus mechanisms keep everything synchronized. These rules help nodes agree on what data is valid. Proof of work and proof of stake are the most common. They prevent false information from entering the chain. Without consensus, blockchain would not be stable or reliable. Core features and principles. Blockchain has several core features that make it powerful. These are decentralization, transparency, security, and efficiency. They shape how modern digital ecosystems function. Decentralization advantages. Decentralization removes the need for central authorities. People can interact directly. This allows faster transactions. It lowers costs. It also increases independence and neutrality. In a traditional system, banks or governments control the flow of data. Blockchain replaces this model with a shared network of participants. No single point of failure exists. If one node fails, the network continues to function. This principle helps cryptocurrencies' blockchain technology expand into global systems. Anyone can join the network. Anyone can verify data. Anyone can send or receive digital assets. The rules are equal for all participants. Transparency and auditability. Blockchain is completely transparent. Every transaction is visible. Anyone can view historical records. This does not reveal personal identities. Instead, users are represented by cryptographic addresses. This creates a trustworthy environment. Fraud is easier to detect. Audits can happen instantly. Organizations use blockchain to track inventory, verify product origins, and store sensitive data. Transparency simplifies compliance and reduces corruption. High-level security, cryptography protects blockchain data. Every transaction is secured with digital signatures. These signatures prove ownership without revealing private information. Blocks are linked using hash functions. A hash is a unique digital fingerprint. If someone tries to modify a block, the hash changes. This alerts the entire network. Tampering becomes nearly impossible. Security is one of the main reasons cryptocurrencies' blockchain technology is trusted worldwide. Even advanced cyber attacks struggle to break blockchain networks. Types of blockchains. There are several blockchain categories. Each category serves different purposes. Understanding these helps you choose the right solution for your project or investment. Public blockchain systems. Public blockchains are open to everyone. Anyone can join. Anyone can validate transactions. Bitcoin and Ethereum are the best examples. Public networks are the most decentralized. They are strong, transparent, and resistant to censorship. They support cryptocurrencies, smart contracts, and decentralized applications. However, public networks may become slower during high usage. They often require higher fees to process transactions. These issues are being solved with scaling solutions such as Layer 2 networks and upgraded consensus algorithms. Private blockchain networks. Private blockchains are controlled by organizations. Only approved members can access the data. These networks are common in banks, governments, and corporations. They offer fast transactions, high privacy, and internal data control. However, they are less decentralized. Users must trust the organization controlling the network. Consortium and hybrid blockchains. A consortium blockchain is managed by a group of institutions. This creates a shared system with multiple trusted validators. It is popular in supply chain, healthcare, and logistics. Hybrid blockchains combine public and private features. Sensitive data remains private. Other data is shared publicly. Hybrid systems allow customized solutions for industries needing a balance of transparency and privacy. Blockchain and cryptocurrencies. Cryptocurrencies cannot exist without blockchain. Blockchain provides the structure, security, and trust layer. Cryptocurrency transactions require confirmation. These confirmations come from nodes using consensus protocols. This section explains how the two interact. It also shows why blockchain enables new financial systems. Digital currency structure. Cryptocurrencies are digital assets. They are not physical coins or bills. Their value comes from supply, demand, utility, and technology. A cryptocurrency wallet does not store coins. It stores cryptographic keys. The blockchain stores transaction histories. When you send crypto, your private key signs the transaction. Nodes verify it. The network records it permanently. Mining and staking. Mining is used in proof-of-work systems. Computers solve complex math problems. The first to solve it adds a new block. They receive a reward. This process secures the network. Staking is used in proof-of-stake systems. Users lock coins to become validators. They earn rewards for verifying transactions. This method is more energy efficient. Both systems protect cryptocurrency's blockchain technology and keep data accurate. Smart contracts and automation. Smart contracts are self-executing programs. They run when conditions are met. No middleman is required. Ethereum popularized smart contracts, but many blockchains now support them. Smart contracts help automate payments, agreements, digital identity, tokenized assets, voting systems, financial services. This automation increases efficiency, reduces errors, and improves trust. Real-world applications. Blockchain extends beyond digital money. Almost every industry is exploring its potential. These applications deliver real value and solve old problems. Financial innovation. The financial sector is the largest blockchain adopter. Blockchain supports decentralized finance, DeFi. DeFi provides access to loans, trading, and savings without banks. It is global and accessible to anyone with an internet connection. Cross-border payments become faster and cheaper. Traditional systems take days. Blockchain reduces settlement time to seconds. Central banks also explore digital currencies, CBDCs. These use blockchain principles to improve national payment systems. Supply chain tracking. Companies use blockchain to track goods from origin to destination. This increases transparency. It prevents counterfeiting. It improves quality control. Industries using blockchain for supply chains include food, pharmaceuticals, electronics, luxury goods. Consumers gain trust. Businesses gain efficiency. Healthcare improvements. Medical records become secure and portable. Hospitals can share data privately. Patients gain control of their information. Fraud and errors decrease. Blockchain supports medicine authentication. It prevents fake drugs from entering the market. Digital identity and data security. Identity theft is a major global issue. Blockchain offers user-controlled identity systems. People store their data securely. They choose who can access it. This model reduces data breaches. It also strengthens online authentication. Challenges and future outlook. Blockchain is powerful but still evolving. It faces challenges in scalability, regulation, and public understanding. Solving these issues will accelerate global adoption. Scalability issues. Some blockchains process limited transactions per second. When traffic increases, networks slow down. Developers work on Layer 2 systems, sharding, and improved consensus methods. These technologies help blockchains grow while staying decentralized. Regulatory uncertainty. Governments continue to analyze blockchain and cryptocurrencies. Clear rules are essential. Regulations must balance consumer protection with innovation. Different countries adopt different strategies. Some embrace blockchain, others restrict it. The future of regulation will influence the global crypto market. Education and adoption. Many people misunderstand blockchain. Education is critical. Beginners must learn basic concepts. Professionals must understand technical details. Companies must train employees. As knowledge grows, adoption increases. More industries will integrate blockchain systems. Summary: blockchain technology is the foundation of modern digital finance. It supports cryptocurrencies, smart contracts, decentralized applications, and secure digital identity. It offers transparency, security, and efficiency. Whether you are new to crypto or an advanced user, understanding cryptocurrencies, blockchain technology helps you see why it continues to transform industries worldwide. Blockchain's future is promising, innovative, and deeply connected to the evolution of the global digital economy. FAQ 1. Is blockchain the same as cryptocurrency? No. Blockchain is the underlying technology. Cryptocurrencies are digital assets that use blockchain for security and transparency. 2. Can blockchain be hacked? It is extremely difficult due to decentralization and cryptography. Most attacks target exchanges, not the blockchain itself. 3. What is the main benefit of blockchain? Trust without intermediaries. The system verifies and records data publicly and securely. 4. Do I need technical knowledge to use blockchain? No. Many apps hide the technical complexity. Still, understanding basic concepts increases security. 5. Is blockchain only for finance? No. It is used in logistics, healthcare, identity management, energy, gaming, and many other industries. Call to action, CTA. Ready to explore the world of blockchain and cryptocurrencies? Start learning today, stay informed, and take advantage of the technology shaping our digital future. Whether you want to invest, build, or innovate, blockchain offers endless possibilities.